What's up, everybody? Welcome back to another video notes here. Pretty straightforward and easy lesson today. Shouldn't take too long. One thing you are going to need, though, is a calculator. So if you don't have a calculator, go ahead and go grab one. Pause this real quick and grab that and then come on back. All right, little recall of histograms. So what we're going to do here is we can see down here that the range that we're dealing with is from 66 to 70, right? That's going to be the first interval range. So we're just going to check out how many numbers we have between 66 and 70. So we would have 1, 2, 3. So and then we're going to look at our tables. This one has 3 here, 3 here. This one doesn't have 3. In this first column right here, it only has 2. And then this one has 4. So that's also not going to work. So now we're going to, we see that 71 through 75, they both have the same. The next difference comes at 76 to 80. So we'll check that out here. Between 76 and 80, there's 1, 2, 3 numbers, and this graph only has 2. So we know it's not A, so our answer here would be B. Okay. All right. 3 different types of measurements to measure the center of your data. You have mean, median, and mode. Mean, you've probably heard of as average. You love to ask me, what was the average on the test? The way that you do this is you add up all the numbers in the data and then divide it by the number of data values that you have. So, for example, in this first one over here, to get the mean, we would do 1 plus 29 plus 23, plus 33, I'm sorry, plus 33 plus 31 plus 30 plus 33. So adding up all of our data values together, and then you're going to divide it by the number of data values you have. So 1, 2, 3, 4, 5, 6 data values. So we put that right there. All right. So I would type this in my calculator. I'm going to add up all those top numbers first. Don't try and do too many steps at one time. When you add that together, you're going to get 157. And then you're going to divide that by 6. And when you do that, you're going to get approximately 26.2 as our mean. So that would be our average number using this data set right here. Okay, median is the middle of the data. So you're going to find the middle number, similar to the average. But now we don't have to worry about this 1 right here bringing our test grades down, right? If we have one really low test score, it's going to bring our average down. So this helps to get rid of those outliers, we call them. The way that you need to do this, the most important thing you got to remember here is that in order to find the middle, we need to write the numbers in order. Okay, we need to start from the smallest number and then write it all the way up to the biggest number in order to find the median. So if we do that real quick, let's go back to black here. We can write these numbers in order. So the smallest number would be 1. After that, it looks like it's going to be 29. After that, we got 30. Then we got 31. Then we got 33 for this one, and then we have to account for the other 33 as well. So now we need to find the middle of our data. The way that I like to do this is you kind of cross off 1 from each side as you go. So you start at the front, you cross off the very front, then the very back, then the next one, then the next one. And if you end up with 2 data values, right here, it says if there are 2 middle data values, calculate the mean of the 2. So what that means is you are going to take these 2 numbers, so right here, you're going to add them together, 30 plus 31, and then divide it by 2 because there's 2 numbers there in the middle. So you got 61 divided by 2, and if you type that in your calculator, you'll get 30.5. 30.5 would be our median there. Okay, so I know it's a little crammed here, but hopefully you're finding some space. Okay, and then mode is going to be the most repeated value, the most frequent number, that you have. And there can be more than one mode. So if there was 2 numbers that have the same amount, then there would be 2 modes. But in this case, when we look, we have 33 and 33, so two 33s and no other numbers repeat. So our mode, our most frequent number, would be 33. All right, so let's try this next one real quick. Mean, we're going to add these together. 8.2 plus 9.3 plus 8.5 plus 8.8 and then plus 9.0. And then we are going to divide that by 1, 2, 3, 4, 5 data values. So we put a 5 there. When we add these together, you're going to get 43.8 divided by 5. And if you type that in your calculator, you're going to get approximately 8.8. So that would be our mean or our average here. Mean or average. Now to find our median, the most important thing, like we wrote right here, write the numbers in order. So when we go back over here, we got to write these in order. The smallest number is 8.2, so 8.2. And then our next one would be 8.5. The next one would be 8.8. Then we got 9.0 and then 9.3. So we got those numbers there. Now to find the middle, we're just going to cancel them out. So we get rid of the front, then the back, front and the back, and now we end up with just one number in the middle, and so our median would be 8.8. All right. When we look here, we see, are there any numbers that repeat? And in fact, there aren't any, so we can say that there's no mode. No mode in this problem right here. All right. So hopefully that's okay. Mean is your average. Add up all the numbers, divide by the number of data values. Median, write them in order. That's the number one thing. And then cross it out, find the middle term, or find the middle number. And then mode is your most frequent number in your data set. Okay, so it says when analyzing data, it is not only helpful to know the center, but also how the data spreads out around the center. So it's kind of asking, in this case, is your data all kind of near the middle right here, or is it much more spread out a little more evenly? Okay, so what we have is standard deviation. What standard deviation is, it has like a little O with a little, whatever you want to call it there. It's how spread out the data is, how spread out. Okay, is it close to the center? Is it close to your average or your median, or is it spread out kind of far? So what this means is a lower standard deviation, a lower number as your standard deviation, indicates that the values are closer together. They're less spread out. Okay, so they are closer together. So deviation means like how far away is it? And so when there's a lower number, it means they're not as far away. They're all kind of closer together. And so using that, we can see that a higher standard deviation would mean that they are more spread out. More spread out. So lower standard deviation means the data is closer together. Higher standard deviation means that the values are more spread out. Okay. You can have multiple standard deviations. You can have like one standard deviation, two standard deviations, and we'll talk about calculating that in just a second. All right. If we look over here, it says match each graph with its standard deviation. Well, what it wants us to see is that this standard deviation is smaller, which means that the numbers are closer together, closer to the middle. All right, so in this case, the numbers that are closer to the middle would be histogram B, because they are all kind of grouped up here in the middle, whereas in this one, they're spread out this way and spread out to the left. So this would be histogram B, and this would be histogram A, because it's more, this one is more spread out. All right, so I guess I can label it with some colors. This one, 30, goes with this, and then this one goes over here with histogram B. Okay? All right. So not too bad so far. You've probably seen this in other math classes. What you might not have seen is what we're about to do next. So this is where your calculator comes into play. We are going to have to be able to input these things by hand. So we got to be able to do what we just did over here. To do it by hand, but we are also going to learn how to use the calculator. So make sure you have your calculator there. and let's get into it. So we need to understand how we are going to input this in our calculator. So it says the first thing is we're going to press stat. So if I open up my calculator here, this looks just like yours. Stat is going to be right here in the middle. Right here in the middle. Hopefully you can see that I can't really show my cursor, but it's to the right of the green one right there in the middle. After that, you're going to click edit. So it's already highlighted, so you can just hit enter. And now you're going to have a list like this. Okay, yours will probably be a little bit longer. What you want to do is you want to input these numbers that we have right here into that list. So if there's numbers in there right now, what you need to do is arrow up over your list and hit clear and then hit enter. And that'll clear all the numbers that you have in there right now. So again, if there's numbers in there right now and you don't want to go one by one, you can click the up arrow, hit clear, and then hit enter, and it'll clear it all out. Okay, so if we're going to input these data values, the first one is 4. So I'd hit 4 and then enter. My next one is 8, enter, 12, enter, 5, and then I'm hitting enter after each one, and you can see it's adding more and more numbers to my list, 5, and then 2. So I have all of my data values in here, and now we are going to have the calculator do the stuff for us here, okay? So now what you're going to do is you're going to click stat again, so that middle button right here, stat, and then you're going to arrow to the right to calc. Okay, one to the right where it says calc. And I'm sure you guys are probably laughing for whatever reason. So what we are doing now is statistics. So what we're going to hit is the top one where it says one variable statistics. You're going to hit enter on that. And then you're going to hit, our list is in list 1, so that's good. And then you're just going to hit enter again. And now it gives you all your data values over here to the right. Oops. So we can see all our data values over here. And the ones that we're looking for right now are the top one, the X with the line over it. That represents the mean. So the X with the line over it is the mean. And then the other one that we're looking for is standard deviation. So first we can write down that our mean is 6, because mean again is the one with the, let's go over here, with the line over it, and that's equal to 6. And then your standard deviation is the one that looks like the little O with the line. So we pull up our calculator here, and that one is going to be the 5th one down. So 1, 2, 3, 4, 5, and we see the little O with the X, and it says 3.16. So we'll say that our standard deviation is approximately 3.16. Okay. It also wants us to explain what this means in terms of our data. A standard deviation of 3, when the numbers are this kind of small, is relatively close to the mean. The numbers aren't real close, but they're not crazy big. Like we saw on this side, we said that a standard deviation of 10 was small, because if you look at our numbers down here, they're much bigger numbers than we're working with right now, because the numbers that we're dealing with are between 2 and 12. So what we would say is this is a relatively close to the mean. The data is relatively close to the mean. Okay, so that's how we do that one. All right, let's try it again with our calculator, and that's going to be just about it for today. And also over here on the right, it shows you all of these different things. So there's mean, and then we have standard deviation right there. All right, we'll get into the rest of this stuff on Monday. So we need to input these data values back in our calculator. So we're going to go to our calculator. We're going to click stat, the one in the middle. We're going to click edit, and I don't want to have to hit delete for all of those, so I'm going to highlight my list. I'm going to hit clear and then enter, and now I'm good to go. All right, good to go. So let's input these numbers in. Take a second to do that. 5, 9, 11, 4, 6, 11, 2, 7, 100, much bigger than the rest of them, and then 95, which is also much, much bigger. So we inputted all of our data values. Now it's time to figure out our values. So we're going to click Stat. We're going to hit Calc. So we're going to arrow over to Calc, and then we're going to hit Enter on one variable, statistics. And for me, it already pops up. For you, it might not. But let's see. There is our data values. Okay, so if you don't see it, just hit Enter, and then you want to hit Calculate down on the bottom. So you'll just go all the way down and hit Calculate. So we can see the X with the line over it is the mean, and that says it's 25. So mean is the X with a line, and that in this case is 25. And then our standard deviation, which is the little circle, that one, let's take a look, says that it is 36.37. We'll round to that first decimal, and we'll say 36. Actually, we'll leave it as 36.37. So 36, approximately 36.37 would be our standard deviation. So what we can see here is that when we look at these first sets of numbers right here, all these numbers are fairly close, right? They're between 2 and 11. But we have these much larger numbers, and what happens is that's going to make our standard deviation way too big. So we'll talk about Monday about when is it best to use what type of data, but what this is telling us is the data is widely spread. And the reason that is because of the 100 and the 95 over here, right? And what we talked about briefly yesterday was that these numbers that are way far away, these are called outliers. So the outliers were 95 and 100. And so these numbers, since they're much bigger than the others, it's going to change your data values, your standard deviation. Okay. All right. So let's do this apply real quick. It says match each standard deviation with one of the histograms below. So a standard deviation of 1 would be data is the closest together. This one would be the farthest apart. And then this one in the middle would just be kind of mixed between the two. Okay, so the data that's closest together to me would be histogram B, because we can see all our data is here in the middle, so our standard deviation would be 1 here. Okay, we can see that the next one, this one, histogram C, is the data is a little more spread, but not quite as spread as histogram A. So this one would be the standard deviation of 3, and then this data over here in histogram A is the furthest spread out. Almost every number has a data value, so this is going to be the standard deviation of 5. All right, hopefully that made sense. We'll talk about